So I'm going to give this presentation as part of the NYU Data Lab on topic models. Thank you all for coming. I know there's a lot of interest, or I at least perceive a lot of interest in this subject, and I know that there's other people in the discipline who are interested. I'm glad y'all have evinced some interest as well. So they're getting very popular, and for a good reason. We have in the world today access to lots of text, and in general this is part of the overall emphasis on text, using text as data. And as topic models have become much more popular and easy to use, they've become much more easy or much more likely to be used incorrectly because people don't understand the underlying assumptions and the actual mechanics of how they work. If you can just download an R package, as many of us can, and run it, and you'll get some kind of results. You might be satisfied with them, but perhaps you should not be. We're going to be talking about lots of ways in which things can go wrong. On the other hand, if they are done well and interpreted correctly, they can be used to give us insight into the content of lots of different documents very quickly and at a huge scale. And given that there are so many different text in the world right now, and they're often divided into papers, speeches, or tweets. We're looking at tweets today. I'm personally a tweet enthusiast. What topic models allow us to do is summarize the information in those documents, and specifically to assign topics. That's why they're called topic models. This falls under the general headline of unsupervised machine learning. So it's not the case that we're going to be deciding which topics we want to look at. Rather, the algorithms that are being employed are going to tell us what topics are actually contained in those documents. As a matter of fact, topics is sort of begging the question. They're topics if it works, right? All we're actually doing is finding co-locations of words, and the idea is, and in practice it's been validated a lot, that we can find co-locations of words throughout different documents that create something that is related to, or we might consider, coherent topics. But calling them topic models sort of gets a little bit ahead of ourselves, and we want to make sure we actually understand what's going on. They also tend to work best with a lot of data. There have been efforts to use them on smaller data sets, and as long as you're very careful, this can be done well. But I would say in general, it's much safer to use as much data as you can. And oftentimes it's not a big problem, given that if what you're interested in is discerning the topics in a small number of documents, you're probably just as well to read them yourself or pay someone to read them. So you're only going to want to use topic models when you have a lot of data. So we're going to talk first about...
What's come to the lot? I mean, it's probably not like
right.
in like standard regression thing where like 500 is fine, but 100 is probably too small. Like what is...
Well, I would say it has to do with basically how much time it would take you to read them. There's an excellent paper about this we're going to talk about later. It's this Quinn et al. Paper, and they break down 5 different ways to analyze text. And they talk about the different dimensions where it's how much substantive knowledge is required, how much time does it take to read, and things of this nature, which provides a good framework as to whether or not topic models or expert coding or crowdsourcing or just reading them yourself is the correct choice. So the first and the biggest topic model is called latent Dirichlet allocation. It came out in 2003. David Bly and these other folks came up with it. What it does is, given the only inputs are the number of topics, it requires the user to choose the number of topics, concentration parameter alpha, and a collection of documents, it produces a distribution of topics. This is what we'd expect a topic model to do. It does not incorporate covariates about the documents, and oftentimes this is the sort of thing that political scientists want to use topic models for. So we're going to wait a little bit and talk about another example in which we can do that. This right here is the classic diagram that explains what LDA does. LDA is a generative topic model. So the fundamental assumption, which as we know is sort of false, is that once we take out the order of the words in LDA, what we're trying to do is figure out what words go in what documents. And so the assumption of LDA, the way that it works, is that it assumes that each document is composed of words that are chosen through this process. So we make assumptions about alpha and beta. These are two priors that we put into the model. And alpha tells us the distribution of topics over the different documents. And then theta is the total distribution multivariate normal, which is very useful for actually solving the algorithm. And so, but, well, yeah, we'll talk about what happens when we change that assumption, make a better, more accurate one.
Can you just quickly go through what it means to say that topics are uncorrelated?
Absolutely. So what this means is that when we're choosing a topic we're choosing the distribution of topics over the document, the fact that we've assigned a certain amount of topic to a specific document does not give us any information about what other topics are assigned to that document. So when it comes to the process of choosing a word, every time it begins anew choosing a topic based on the distribution, like if we were being realistic, a more realistic assumption that we're going to talk about later is that, in fact, we know that some topics tend to be correlated with other topics. And so seeing certain words in a document beforehand will allow us to update as to what topic we should be drawing from the next word. But with straight up LDA, we don't make that assumption. So each topic draw is independent.
Does that lead to bias, if that's the right word to use, or does that just make it a less efficient algorithm?
It makes it a less efficient algorithm. And I can talk about, in the other model, the correlated topic model, I'll talk about in what ways it improves on LDA. Okay. And finally, and this is a similar point, this is that words are all exchangeable. So just as seeing what words are already in the document does not allow us to change the distribution of topics that we draw, neither does it allow us to change the distribution of words. So each draw is completely independent. And we'll talk about how that is also unrealistic and can be improved on. Here's a nice little quote. This is a piece by Grimmer and Stewart in Political Analysis called Text as Data. It's an excellent introduction to the topic. You should all read it. And they update a classic quote about models, and they say all quantitative models of language are wrong, but some are useful, and I think that that is correct in this case. So let's actually talk about how LDA works a little bit. We're not going to go into too much detail because it is very, very complicated. So again, the only actual observed variables are the words that are in the documents. And what we are interested in is figuring out these two latent variables, which are the distribution of words over topics, called beta, and the topics over documents, alpha. So in the first paper, in the Blei 2003 paper, this is done with variational inference, and later on it's mostly been done with Gibbs sampling. In general, what these two things do, these two methods do, is we have these different parameters, and in order to estimate them, we want to optimize one of the variables while holding the rest constant and iterating across all of the variables. And thus, after a while, we'll reach a stopping point where none of the variables really change, and that's when we figured out that the model has converged. So that's basically how LDA works. So if you're interested in using LDA, what do you do? If you have these texts that's organized as documents, what steps do you take? We're going to get into actually doing it in a second, but for now, I'll give an overview. First, what we want to do is come up with a sparse matrix representation of the words that are in the documents. This is called a document term, or sometimes a document feature matrix. So because obviously if they're just text, it's very difficult to analyze what they are. What we want to do is create a matrix which has the documents as rows and the words as columns, and only put in numbers to represent the presence of a word in a document. We're going to want to remove stop words. This is sort of an art in and of itself, but in general, we think that there are certain words in the English language or any language which are not actually interesting when it comes to determining what topic we're talking